Yeah, so as Uwe said, this was a talk that was supposed to be given by tourists. I think that's kind of be my secret, to let everybody think tourists is going to give a talk, and then I'll show up, slip in at the last second, so people will be there. So, and I think also whoever gives this talk gets to decide what the future is. And I did that in the last 5 minutes, putting these slides together, by the way. Okay, so the talk is OpenNMS today, or I think he said now and the future. When tourists called me a few days ago and said, "I'm sick, can you come give this talk?" I said, "Sure, give me the deck," and he said he didn't have one. So, so I'm kind of making this up as we go, literally like 5 minutes ago. But anyway, we all know this famous landing page for OpenNMS, and it's been like pretty much the same page since day one, which was like 2000. But it has had some adaptations, and we keep bolting onto it. And I think that kind of segues into the future. You know, it's probably something that we should be addressing, and I'll talk about that a little bit. So OpenNMS now. So we have two distributions of OpenNMS. For those of you that don't know, you probably all do, but we have OpenNMS Horizon. OpenNMS Horizon is the release that gets put out at least twice a year. It's been about 2.5 times a year as I go back and calculate how many releases. That is an analogy. If you want to use an analogy, it's like Red Hat's contribution to Fedora. It's an open source project moving fast and governed by the community, and certainly not as stable as what we call Meridian, which is our Red Hat Enterprise Linux. Meridian gets an annual release and is based on a release of OpenNMS that's been vetted by the community, the most stable release with the most features that we have. Okay. So currently we're on version, well, I thought we were going to be on version 23 today, but we were going to do that, I think maybe next month. Horizon 23 will be released. We usually release on the third Thursday of every month. We use an agile methodology for development, thanks to our German counterparts here in Europe. We're pretty quiet about what we did in the past, and now we do everything through our issue tracking system. We have a good process for getting everything into our workflow in Scrum and through our Jira tracking system. We also have a lot of good workflow through GitHub. Thanks for GitHub. It's pretty much a quarterly release we'd shoot for, but as I said, we started out with Horizon back in 2014. That was the first time that we had done the split of OpenNMS. Before, we always had a stable release and an unstable release. And it really slowed down development because the stable release is what we used for support with our customers. And we also were pretty tight about taking contributions, because anything that came in, we'd end up having to support immediately to our customers. So with Horizon not being supported, or at least not with our primary support, we can move a lot faster and take contribution a lot easier. We drive Horizon by features and by schedule. So when we feel like we've got a bulk of our features into the software that's ready to make a release, then we'll do that as quick as possible and get it to the community to vet. We do provide support. The OpenNMS group does provide support through our Ultra support contract versus our Prime support contract. And all of our major features that are sponsored by customers, all those features go into Horizon first to be vetted, and then will later be put into Meridian. Which gets me to Meridian. So we're currently on version 2018. We do one Meridian release every year. that's been 4 releases, I guess, now, and so we support Meridian for 3 years. So once we get beyond the 3-year date, it becomes end of life, and I think that means that our first release, Meridian 2014, now is end of life. We also use an agile development methodology there, but we do go back and we do plan maybe 6 months in advance what version of Horizon is going to be used to make this release. And again, we do an annual release, and it's based on features and stability rather than schedule. So we try to get something out as quick as possible to the community with Horizon, but with Meridian, we wait for something to be worthy of release and it's stable and been vetted by the community. By the way, this is supposed to be an hour talk, so if anybody has a question as I'm going here, please ask questions because I'm going to run through this probably pretty quickly. Again, Prime support is what we use for Meridian. So if you contact the OpenNMS group and you want us to give you support while you're using OpenNMS in production, we'll require that you run our Meridian release. Okay. So those are the releases. We have a few projects or big projects within OpenNMS that we give some sort of name or moniker. One of the first that we've done this and branded fairly well was Newts. I'll talk a little bit more about that in detail, but Newts is a scalable way to store your time series data. Compass is a mobile application that we developed a few years ago, and it runs on Android and iOS, and I'll cover each of these in more detail in a few minutes. Minion was a big project for us. This is something that allows us to have visibility into networks where OpenNMS can't reach, and I'll talk a little bit more about that, but it was a fundamental change to the way OpenNMS does monitoring, and it pretty much it works like a proxy. Helm is an application plugin that goes into the Grafana open source project for building time series dashboards. We also have a fault management plugin for that. Drift, and if you notice the colors, so the colors are this Meridian blue, so these are features that are available in Meridian. And this Horizon green is something I'm using to show that these features are currently only in Horizon. So Drift was a project that we had sponsored from one of our 3 Fortune 5 companies in the US. Drift is a way to get streaming telemetry into your system rather than using SNMP to gather metrics. A lot of companies are, like Juniper and Cisco, are promoting doing SNMP-less monitoring and being able to stream this telemetry data into your system. So we have support for those platforms. It also supports flows, and I'll talk more about that here in a minute. Sentinel. Sentinel is another project where we have started, and I think I don't know if it was in 22. Jesse, was it in 22? Yeah, so I think it'll be, the first release will be in 23 that you'll see. Sentinel is a way to horizontally scale the processes in OpenNMS that need to grow for the size of your network. So instead of constantly tuning a single instance of OpenNMS to try to make it do all the work, you can run one or more Sentinels and get that scalability that you need in your data center. I think the asterisk means future, so this is again now and future. So I'm talking a little bit about the future here in this part of the talk. Sexton is another project we started with one of our great sponsors, commercially. They asked for correlation in OpenNMS specifically to replace some products like Smarts and Cisco Prime Network in their environment. So we have embarked on a correlation framework for OpenNMS that we call Sexton. Okay. So this kind of illustrates what it looks like from perhaps in your data center. So there's a lot of moving components here now in OpenNMS. You know, we've gone from having this single JVM process running on your server in a data center to quite a few components that you can stitch together to scale and get reachability for your environment. So let's see if the pointer works. Yeah, here we go. So what I've shown here is, for example, a remote office where you might have minions running. Now these minions would be able to see things in that remote office that OpenNMS can't see from the data center. And I'll talk a little bit more about minion coming up, but it also helps handle duplicate IP addresses. So if you have remote offices with reusing IP spaces, then you'll be able to cover that with minion and not have any problem in OpenNMS. So there's the minion. These are the different types of data. We have fault data, we have flow data, and we also have telemetry data that can stream through the minions and come into OpenNMS. So this area here sort of represents your data center. Here's OpenNMS at the top with visibility from our Helm application and Compass that I talked about. And then here is a message broker. So OpenNMS has support for a few message brokers. One of them, as I show here, is Kafka. So Kafka is really a nice messaging system for scaling in your data center and getting rapid data coming from your minions into a scalable, stable solution to be processed by OpenNMS. Let's see. So these here are sentinels. So here's where you can scale up OpenNMS to be able to process more load. For example, at the sponsor of the Drift project, we are processing somewhere between 200 and 250,000 flows per second in their data center and getting those into a big data storage called Elasticsearch. So we're using Elasticsearch to process flows and store them and analyze them. And then we have, here I show ScyllaDB, but it's actually a Cassandra or ScyllaDB backend for time series data. And then our normal Postgres ecosystem here for the inventory and vaults. Any questions about that slide, please? We're going to run out of time here. I kind of zoomed in here a little bit to talk about newts. So it does replace RRD. I feel like we did a fantastic job with newts because you only need to change one flag in your, and it's just a configuration property in OpenNMS to go from storing data with RRD to a backend with Cassandra or ScyllaDB. So you change that one flag, and now you have horizontal scalability and data replication between data centers. So it is a fully abstracted API. So when we decided to not use RRD, we had to come up with solutions for things that RRD provided that we didn't have. So we needed to be able to not only store the data, which RRD gave us a storage mechanism, we needed to be able to have a graph the data. RRD came with graphing engine, so we had to come up with a project. It's one of the, I think, 3 different JavaScript projects we have. It's called Backshift. We use that to graph data now, and you can use RRD tool with Backshift as well, and you don't have to wait for putting in Cassandra to use it. You also need a graph definition language, so RRD tool provided a language for describing what the graph would look like, so we went ahead and just reused that language, but doesn't require that you have RRD to be able to graph. You can graph using it, so you didn't have to change any files at all in terms of the customized graphs that you had created. And it does scale horizontally. So you start to have problems with getting data into your persistence engine, then you just add another node in your cluster and you get linear scalability. And again, like I said, it does support Cassandra and and or ScyllaDB. We have a lot of customers right now that are taking a good look at ScyllaDB because of its promises for managing the clusters easier and sizing and sizing of the servers needed to run it. Okay, Compass. So Compass does run on iOS. It also runs on Android. And it does have user actions as well. So you can not only look at graphs and look at alarms and look at inventory, you can also make changes with it. Compass is also customizable, so you can kind of pick the graphs and things that you want to be able to see right on the dashboard of the Compass application. But one thing Compass really did was made us work harder at our REST API because it's not running right there in the Java process and has access to all the libraries and code that you would need to present data. So we had to work really hard on a REST API to get Compass to work. So now we're back to Minion. And the really nice thing about Minion is that it's stateless. It uses a competing consumer design pattern on a queue. So when Minion starts up, it's told where OpenNMS is and where's the queue for its work. And we have two APIs in Minion. One's an RPC API, and one is a sync, S-I-N-K API. So for autonomous messages coming into Minion, we use a sync API. It just receives a message, publishes it on a queue, and then OpenNMS or a Sentinel will process that data. It also uses we have an RPC API for jobs or tasks or actions we want the Minion to perform. So OpenNMS will put a message on a queue that the Minion will read and then execute that in its location and do its poll or do its data collection for seeing. So I kind of say that Minions are the eyes and ears of your network in those remote locations. It does act as a proxy for getting data in and out of a secure network. So that makes it very cloud and data center friendly. Okay, and so Helm. So Helm is a plugin that goes that runs in Grafana. Currently supports Grafana 5. The plugin has support for fault management data. So any alarms in OpenNMS you can present in the Grafana console using all the Grafana tooling around it. I think Jeff has given a talk on Helm, right? Yeah. Okay. So he'll cover that in more detail. It does have our first implementation was performance management data. So traditionally, Grafana has been used to show time series data. So we wrote a plugin for Grafana. We wrote a plugin for Helm to access the performance data. And it uses what's inside OpenNMS is a pretty extensive measurements API. Again, that's abstracted behind, in front of OpenNMS so that if you're using RRD or Cassandra, then the performance management or the measurements API will present the data the same. It also has a flow data source. So if you're storing and processing flows and storing them in Elasticsearch, it will also look in Elasticsearch for flow data. And it does support multiple OpenNMS instances. So if you want to see data in a single fault management table, you can tell it to say, give me all alarms related to, say, a Cisco switch across all my OpenNMS instances in a single table. You can also put time series data for multiple instances on the same instance of Grafana or Helm. Okay, so Drift. So Drift was a pretty big project, as I said, was sponsored by one of our Fortune 5 customers in the US. It does support flows, so that's NetFlow v5, v9, IPFix, JFlow, and SFlow. So all those flows come into OpenNMS, and the data is normalized and attributed with things that will make it easy for you to search and find inside Elasticsearch. But we also have a plugin in Helm for analyzing the data as flow data. So you can see records of conversations and top protocols that are going through your network. We do have support for that in Helm as well as Minion. So if you want to send your data through a set of minions versus directly into OpenNMS, you can use Minion to scale that and provide availability for that flow data. And we use Sentinel to process that data. So Sentinel will be watching the queues as the flow's coming in, because 250,000 flows per second would be something that a single OpenNMS instance wouldn't be able to do. And I think I have a little video here showing how you can navigate quickly from OpenNMS using a little widget on a graph. So when you're looking at a graph in OpenNMS, if there's flow data for that particular resource, there'll be an icon that you can click, and we call that our deep dive tool. It'll jump into Helm. It'll present Helm with the same time range that you're looking at in OpenNMS, and it will allow you to jump in and look. Not only did I have a bandwidth peak, but what's inside that bandwidth. So what protocols were being used and who was making those conversations across during that bandwidth. Okay. So here's Sentinel. It is containerized, so we've been working hard to make OpenNMS more elastic, hopefully to get OpenNMS to be able to run in a cloud environment, whether that's OpenStack or AWS or whatever. But we are containerizing a lot of the components in OpenNMS, and Sentinel is one of those that now runs as a Docker container. So that we can achieve some horizontal scalability and make it easier for you to spin those things up and down while you're running in a cloud environment. It is stateless as far as I know. There might be state that's leaked into Sentinel that I don't know about, but the goal was to be able to have those start up and be torn down by something orchestrating the environment like Kubernetes, so that we don't have to worry about moving that state around while Sentinels are running. And we're also working on, I think, working on some HA work with leader election and that kind of thing in Sentinel. Okay, there might be a talk on that this week. Sextant. It is a project that was sponsored by one of our customers for correlation. It's I think probably one of the most ambitious projects that we've taken on. It does use algorithms from linear algorithms using machine learning. That's supervised and unsupervised machine learning. We currently have something that's being prototyped by the customer using one of these machine learning algorithms that's providing correlation. And when we correlate alarms with this engine, we call them situations, and you're able to visualize these situations, and currently only in Helm. We also have been building some infrastructure in there for training the system. So even though we don't have the algorithms yet, currently in the UI, the users are able to give OpenNMS feedback about how well it did in the correlation, identify root causes, remove things from the correlation, add things from the correlations, hopefully to train the system to get better at what it does. Then we're looking to use some AI to do other things, a little more advanced, like some pattern recognition for looking at anomaly detection, looking for anomalies that are occurring in your network that you might not be aware of, that may seem fairly mundane, but sometimes an anomaly would happen that might be interesting in your network. For example, I was reviewing this use case with one of our customers that works in the healthcare environment. And they were asking me if they had had a security audit recently, and they found that once somebody found an opening in their network, which was an old version of Tomcat running some application that still had the administrative password wide open on Tomcat, they were able to get into their network. And they said, how would this have been able to help us? I said, well, if the instrumentation was there, we would have been able to see that somebody logged into that Tomcat instance from a log message, based on a log message that maybe nobody had logged into for a year or two, as the case had been. And that would be an anomaly. So even a successful authenticated login from a log message could be an anomaly that you'd be interested in knowing about. We're also looking to be able to do some sort of predictive behavior, so some pattern recognition to be able to look at faults and look at flows and look at performance data and be able to do some predictions using some AI technologies. And I repeat myself. Okay, so what time is it? 10 o'clock? So I took quite a bit less than half an hour to talk about OpenNMS now, and so I have the other half, the future. Do we have any questions? Anybody have a thought? Okay, so I get to decide what's the future. All right. We're closed sourcing OpenNMS in 2019. Okay, so one of the things that has been the bane of OpenNMS's existence, I guess, and maybe even Jeff's existence, is the complexity of OpenNMS. And all we're doing with all this work to make OpenNMS scale is making it more complex. And I think that's something that we should be addressing. So I don't know why I like this slide so much, but I was trying to find a way to, or this cartoon, to find a way to put it in. But so I really would like OpenNMS to have Siri and just say, hey Siri, add the node, right? I don't think it'll be quite that simple, but I think that we have a multifaceted set of complexities that we're dealing with when we're looking at using OpenNMS. Sometimes the complexities are so enormous that I wonder why people stay with OpenNMS. But I think the value and the benefits are there. You just got to get through that first set of complexities to get there. So infrastructure. So again, here we're talking about, I don't know if I have any bullet points on that. Nope. So anyway, infrastructure. So we're looking at not just OpenNMS and Postgres, what we used to only have to worry about in OpenNMS, is making all that HA, making Postgres HA is difficult on its own, right? So then we have, what do we have on top of that? So we have Minion. So for Minion, we need a communications infrastructure. And as I said earlier, we support like 3 different messaging protocols. So we use JMS by default. We also use Kafka, as I showed earlier in the slide. And if you're running OpenNMS at Amazon, we even support, what's the Amazon messaging system? SQS, yeah. Input from the group, yay. So yeah, so there's that infrastructure. So you have Kafka, and if you want, or ActiveMQ for JMS. If you want to make that scalable and stable, then you have to put that infrastructure in. And then Sentinels, right? So if you're going to run flows or anything that's requires a lot of work in OpenNMS, then you're going to need to install Sentinels, and probably, since it's containerized, you'll want orchestration. You'll probably want some sort of configuration management as well, orchestrating the configs. So you're looking at something like Kubernetes, or I think we talked last night, like Ansible or Puppet or something like that to manage those configs. So the infrastructure of OpenNMS is, now we got Elasticsearch on the back end for flows, right? And we have Cassandra on the back end for performance data. So now you have those 2 clusters that you need to learn to scale and deploy in your environment. So we need to find ways to address those complexities. One of those obviously would be putting them in the cloud and using Elastic services from the cloud. And maybe OpenNMS becomes a service as well. So we could just You could just go to OpenNMS.com, say create me an NMS, and boom, you'd have all that infrastructure, right? So, and hopefully shared infrastructure, so it wouldn't be so costly. So that would be one way to address it, but certainly we need a way to figure out how to address this complexity, either through training and documentation, or just finding a way to make those tools easier to deploy, even from OpenNMS's perspective. Configuration. So one of the famous quotes that you'll hear around the old guys in OpenNMS is that OpenNMS has too much XML, right? So you'll see that's, you'll see that OpenNMS is very flexible in its configuration, and most all that configuration is XML, and almost all that configuration you have to do by hand. There are some tools in the UI to help you do that on things that are more repeatable, but there's still an awful lot of things that require SSH, console access, and editing XML files to make happen. So that's a fairly complex task that is, when somebody's new to maybe Linux or new to looking at XML or even new to OpenNMS, is getting over the hump of how to get it configured. Now, kind of the beauty of it is once you've trained yourself to do that, you've learned a lot, right? These are skills that will take you not just from OpenNMS, but into other products or other systems as well. But it is still complexity. And maintenance. So diagnosing OpenNMS. Who here has ever looked at an OpenNMS log file? You can't run OpenNMS without looking at a log file, because at some point you're going to go, I wonder why this isn't working. And really the only way to do that is to look at the logs. So we've been pretty diligent in the code to write a log and with debug information, but we're not really exposing that very well to the user in a consumable way. And we're not putting intelligence back into the system to look at things that we've identified as problems in the past to make them easier to recognize in the future. So we need to find ways to address this complexity. Okay. Again, I did these slides like 5 minutes ago, so I don't really even know what's on the next slide. So again, I wanted to just present this to you, that it is worth it to work to get OpenNMS up and going in a large enterprise. Like I said, we have 3 of the Fortune 5 in OpenNMS, some very large financial institutions that are running OpenNMS. And they're the ones that are asking us to put all this in, but typically they have the resources and the capacity in their organization to build this stuff. Right? And they already have domain expertise that they can leverage. But for a medium-sized enterprise, for example, that somebody says, hey, I need to monitor this stuff. Oh, cool, it does flows. You're looking at a lot of learning there, a lot of time to figure out Grafana and Kafka and Elasticsearch and Sentinel and Minion, all those things that you'll probably need to get your flow processing working. Let alone just all the little bits around Postgres and things like that. Do I even have another slide? That's the next question. So I just wanted to show again some complexity. So here's some of that XML. I'd forgotten I'd done this. But so you can see here this little metric here that we're configuring OpenNMS here to say, go using SNMP, go talk to it using this this object ID and get this value using SNMP. So once OpenNMS starts up, and there's more to this than just these few XML elements, but this was as much as I could fit on the slide. But go grab this piece of data every 5 minutes, let's say, for example, and store that in OpenNMS, whether that's Cassandra or RD. Now, once I've got it, I want to graph it. So here's this little metric again. Now, these are all configs that come with OpenNMS, fortunately. So if you have an NXOS environment, here's some things that came packaged up with OpenNMS so that you could see these values, right? So now I have this fairly complex graph definition that I'm going to have to create to be able to see this value. And then, what do I got here? Oh, and this is for thresholds. So if one of the things I've said about OpenNMS forever is that even if we're collecting millions and millions of metrics every 5 minutes, we only ever look physically or visually at maybe 0.1% of that data. But there's a lot of data there to be looked at. And so one of the ways to do that is with software, and one of the ways we have that in OpenNMS today is with thresholding. So now we're taking this same metric here and we're looking at it with this fairly complex threshold configuration for analyzing had it breached some threshold. Hopefully we'll be able to do this kind of automatically with AI in the future, but this is what you got to do today just for one metric to be able to go get the data, graph the data, and then analyze the data. So it's a lot of configuration just for one metric in the system. Again, fortunately, a lot of this has already been done for you, but if you have a new piece of equipment, you want to do this yourself, it's a fairly complex task. And if you want to change it, then you'll have to understand how all this works together. Do I have another slide? Let's roll the dice. Okay, so one thing I wanted to do is Uwe noticed that I got my iPhone working to move the slides, so I was going to see if I could just do that over here. So diagnostics is one of the things that makes OpenNMS very difficult to use in your environment. So I think one of the biggest questions we get in support is, why is there no data in my graph? I don't know. Right? I think Mikhail is shaking his head as well. I think he supports a lot of customers here in Germany. It's a very difficult thing to figure out, mainly because the configuration is complex. You may have messed something up. Networking systems are notoriously finicky, right? So somebody's changed DNS. DNS is always a problem, right? Somebody's changed the firewall rule. I can't get it anymore. But how do I know that? Really, the only way is to look at logs and maybe even use packet captures to be able to see, is the agent even responding? So diagnostics is pretty difficult, and what we need to do is figure out a way to make that easier right in the UI and be able to do that with software. And it's all doable, it's just time. Upgrading OpenNMS can be difficult, right? Who here's upgraded OpenNMS? Who here decided a long time ago to not ever do another one? Hire smarter people than me to do it, right? So upgrades can be difficult at best. We do have a lot of infrastructure in the install packaging to make that as easy as possible, but it can be a little tedious to migrate those configs. So we need to find ways, maybe even to be more DevOpsy, right, to make OpenNMS easier to upgrade in place. Nobody backs up OpenNMS. I'm telling you. Has anybody here ever put together a solid backup infrastructure for OpenNMS? Okay, we got a couple. So part of the problem is that while it seems simple to do, getting that also in a way that you can restore it is pretty difficult. So, and just knowing what to back up, and again, with all these new components to the infrastructure, it's getting harder and harder. I like this. It's pretty cool. Roll the dice. I don't know whether I got another slide or not. So kind of some of the questions like, why does our community, why do you guys put up with this, right? So it is open source. So you kind of have, you're not bound to some vendor to say, here's what I'm going to charge you for licensing. Here's how I think that that your NMS should behave. You have the ability to make changes yourself, contribute, and it's a more sustainable way, I think, open source has proven to sustain your business. So we do have a lot of customers or a lot of companies that are approaching us, even emails this morning saying we've got a mandate to move to open source and we're getting rid of our traditional monitoring tools from IBM or whoever, HP or whatever, so that they can have a more sustainable future with an open source tool. So there's a good reason, right? When it comes to open source monitoring systems, there's really only one open source monitoring system, which is OpenNMS, out there that's available to be truly an enterprise deployed monitoring system, I think. Especially with a lot of the integrations that I think Jesse White will talk about later, either today or tomorrow. Everything that's coming into the system is consumable through an API. So I think that really makes OpenNMS an enterprise-worthy application. It's actually the only application out there that is really doing hyper-scalability. And having deployed a lot of other monitoring tools in my life, and not just commercially, but also open source, I can say that I wouldn't even know how to approach some of the numbers that OpenNMS is able to achieve with other tools. Super flexible, again, all that difficult complexity in XML also offers a super amount of flexibility, right? I can make it look any way I want to look. There are a lot of APIs for accessing that data. There's a lot of tooling. I had slides earlier about some of our pet projects like Drift and Sentinel and Minion. But we do have 3 JavaScript projects. One's called Backshift, which is if I want to graph things that OpenNMS has and I want to use my own web app, but I don't have to write some graphing engine, I can use Backshift right in my own application for displaying data from our measurements API. You don't have to write that yourself. We also have OpenNMS.js. So OpenNMS has its own JavaScript library now for consuming data from our API. So you don't have to write serialization code for looking at JSON or XML. You can just use OpenNMS.js for marshaling that data. We actually use it now in all of our UIs. So in the web app as well as Compass, and I think it's used in Helm as well. Is that right, Ben? Is OpenNMS.js in Helm? Okay. This might be the last slide. Yeah, it's the buffet of NMSs, right? So everything that you're doing with monitoring pretty much has a feature in OpenNMS, so you can consume everything into OpenNMS. And we're also in real time tagging all that data and storing it into the back end. So Elasticsearch, if you wanted to look at data that's coming in from OpenNMS, from faults to flows, and look at all in some tool like Kibana, it's all tagged with the categories that you've put in. All that data is indexed and put in Elasticsearch so that you can look at it. So whether it's syslogs and flows and fault data all at the same time, it's all tagged so you can relate that into a single chart. I still have more slides. How are we doing? I was supposed to stop at 10:30, right? I'm doing better than I thought. So we do want to build a cloud offering for OpenNMS to make it easier, even if you just want to try it and then go deploy it yourself inside your own data center, or if you want to run it in production. Again, one of those 3 messaging systems that OpenNMS supports, JMS, Kafka, and SQS, so we're looking to put in whatever cloud provider's messaging system to make that work. So a company in the US that provides Wi-Fi on airplanes came to us and they wanted to use OpenNMS. They wanted to deploy it in the cloud. And we spent a lot of time working with them getting processes in place for a DevOps infrastructure for running OpenNMS at AWS. They also were learning AWS at the same time as we were. But we wrote an implementation of our sync and RPC APIs in SQS. And so I think that might help reduce some of that complexity, being able to just put it in the cloud, and you don't have to set up at least that one facet of complexity, the infrastructure. Another thing I think we should do in the future is make the configuration more of a wizard and not something that I have to kind of understand the model to be able to configure OpenNMS. So in that, like that XML example I showed, where I'd have to know that in this configuration file, say collect D, I'd have to tell OpenNMS how often to collect something in the collect D configuration. In the data collection config, I'd have to define what metrics I want collected. In the SNMP graph.properties, I have to define the graph definition. So I would want to be able to have a wizard that would say, hey, I want to add a node, and there's a metric out there on that node that I want to collect. And just have it walk me through all that in a very nice wizard that would say, now generate whatever XML, I don't care on the back end, but just make it easy for me in the UI to be able to configure. It's all doable. I think that we have all the back end APIs that we need to do that, but what we need is just the time and capacity to go put that in. And I think in terms of features and scale and things like that, OpenNMS has been working really hard since day one to be this super scalable NMS, but to make it accessible is probably our next step. And for the diagnostics facet of complexity, we really need a way to have we've been working a lot to put a lot of instrumentation in all the in the application. So in OpenNMS today, a lot more JMX is being used to be able to understand what's going on in OpenNMS. We still need more of that, but we've done a lot of work to instrument OpenNMS, especially all the new components like Minion and Sentinel, to understand what the health is. We're also monitoring that infrastructure of Kafka, Elasticsearch, and Cassandra. So out of the box, if you have OpenNMS, and even if you're not using Cassandra for your persistence of time series data, but using it in your organization for other things, you can still very, very well monitor the health of Cassandra with OpenNMS, because we've put config in for monitoring Cassandra just in case somebody's using that with OpenNMS. But again, we have a long way to go, and all the instrumentation, a lot of the tooling as well is done within the Carafe shell, so you can access the OpenNMS tooling with SSH. So you can log into OpenNMS via SSH, get authenticated through the Java security, and run commands to diagnose and see and test different components. But again, here we are, we're at the command prompt, right? We really need to be able to work and get a visualization of those tools and those diagnostics easier and more accessible in OpenNMS. And that might be it. That is it. That's done. So I don't know if that really covered the future of OpenNMS, but it really is kind of what I think we need to do to make OpenNMS successful in the future and more accessible to more people. So getting OpenNMS in the cloud, putting more tooling in for configuration and diagnostics. And it certainly would go a long way to supporting OpenNMS, at least from a commercial aspect, more sustainable. I think that our support guys are phenomenal, right? You know, we have a lot of customers running various versions of Meridian, some customers with Ultra support running Horizon, and those few guys are supporting the world on OpenNMS, and it's amazing. And if I lost one of them, I think we would just be done. So we really need to make that easier for the user to do, and so that we don't have to do that for them. And that's it.